Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and in the previous lectures, we looked at how to critically access the primitive array type in C++, and then how to actually ask JVM to give us direct raw pointer to a primitive array. And the similar story is for the strings. We can critically access strings in C++. So in the lecture that we had about strings, we said that we can ask JVM to and use the function get a string UTF-chars, and we pass in a JString reference. This is a pointer, and then it also takes the isCopy argument, right? So there's so in general, depending on the JVM implementation, it might give us a direct pointer, or the JVM might copy the actual string, Java string, which is on the Java heap. JVM might create a copy and give us a pointer to that copy. All right. That's why we also have this isCopy, and this get a string UTF-chars returns a const char pointer, gives us a raw pointer. And this is a C style string, const char pointer. This is a primitive pointer. And again, whenever a JNI function gives us a raw pointer using any of the functions that start with get, there is another function that it starts with release. So if we use get a string UTF-chars, we should eventually call release a string UTF-chars, right? Release a string UTF-chars. And then if you use the hotspot JVM, which is what I'm currently using, when you use this get a string UTF-chars, this isCopy always comes back true, which means the JVM is actually creating a copy of the original string and gives us a pointer to the copy to that string, right? Note that strings are immutable, whether it's a Java string or a C style string, they're immutable. That's why we have this const here. However, this copying might have significant overhead if you are processing many Java strings in C++, and JVM allows us to directly manipulate Java heap for strings using critical access, and the function is get a string critical, and again the string JString pointer and isCopy, and this time if we use this function, isCopy comes back false, which means JVM is not creating a copy of the actual Java string, and it gives us a direct raw pointer to the string on the Java heap. But here's the problem. So the C style string is a const char pointer, and char is 1 byte because C style string uses UTF-8 encoding, or basically it's ASCII. ASCII is 1 byte. However, Java uses UTF-16 or 2 byte encoding for each character. So it doesn't directly give us a C style string, it gives us a jchar pointer. And if you recall in our lecture on the primitive types of the JNI, we said that jchar is unsigned integer, which is 2 byte. So jchar maps to an unsigned short in the C, all right? So this is a primitive pointer, but this is not a C style pointer. So I cannot pass const jchar pointer to a function, a C function that expects a const char pointer. It doesn't happen. However, when we use this critical, very similar to the arrays, we said that we need to make some promises to JVM, and one promise is that we shouldn't basically call any arbitrary JNI function in between calling this get string critical and release a string critical. All right. So again, JVM is giving us a const jchar pointer, which is a raw pointer. So it means that there is another function that starts with release a string critical, and we pass in the original JString pointer and this const jchar pointer. All right. And again, JVM is not creating a copy. However, when we call this, JVM tells garbage collector that now the string is free. We are done with that string, and then the garbage collector can actually index it and collect it if the string goes out of the scope. All right. So again, the main difficulty here is that when we use this string critical function, it's good because we know that there is no copying happens, but then the problem is that we don't get a const char pointer, we don't get a CS style pointer, we get a const jchar pointer. So we kind of need to manually convert this const jchar pointer to a const char pointer so that we can work with the ASCII encoding in CS style in the CS style fashion. All right. So I'll show you how to actually convert this const jchar pointer, which is 2 byte UTF-16 2 bytes, to a const char pointer, which is UTF-8, or ASCII, which is 1 byte. All right. So let's head to Eclipse and try to look at this. So I've created a new package, test28, and created this class, a string critical access. So I'm loading a dynamic library, and then I have two static native methods, print a string regular, and I send a Java string to C++, and another native method, print a string critical, and I'm sending a Java string to C++. And I have two test methods. Test one, I create hello, how are you doing, and call the print a string regular. So the goal is to send this Java string to C++ and then print it on the console. In test 2, I'm doing the same thing. I create this Java string hello, how are you doing, and then I am calling this print a string critical. So the first one, for the first one, I'm going to use the get a string UTF chars, get a string UTF chars, and in the second one, I'm going to use the JVM get a string critical, and see the differences. So, and again, the routine is that we select the Java file that has the native and then run the Java H tool. It creates a header file, puts it in our header folder of the C++ project, which I've already done. So this is test28. This is the header file for the first basically method, print a string regular, and then print a string critical. And then we go to our src folder, create a cpp file, which is a compilation unit. I have already included the header file, test28 string critical access.h, and I want to print something to the console, so I'm going to also include the IO stream. We don't really need to include the C string, but if we want to use any of the functions that work with CS style strings, we should include this CS string header file. All right. So I have two methods. In the first one, print a string regular. What I'm going to do, I'm going to use the get a string UTF chars, and we know that the JVM is probably going to create a copy of the original string and give me a pointer to the copy. All right. So there is copying happens behind the scenes. So let's test that. So const char pointer, let's call this st, a string chars is JVM get a string UTF chars. So J string is st and is copy. So let's create this is copy, J boolean is copy, and I'm initializing it to false. And then here we have to pass a reference to this is copy. And then we're going to print the is copy first, std cout, and then is copy equals, and then std bool alpha, because I want to convert this J boolean, which is 1 byte unsigned char, to be printed as a true or false. So bool alpha, and then is copy, and then std and L. However, this is a char 1 byte, so what I need to do, I need to convert this to actual bool, so that it understands. Bool alpha works with the C++ bool type, not the char type. So I'm going to convert this char, which is 1 byte, to bool, which is also 1 byte. And after that, I'm going to just print the string st chars, because std and L, because I know that this insertion operator for cout is also overloaded for the st chars, for the CS style string. And to refresh your memory, the way that CS style string works, CS style string is that it's an array of char, and then it has a null termination, which means it terminates with basically 0 character, and we have to escape it otherwise. So there's a difference between basically the 0 symbol, this is a character, but when we escape the 0 with backslash, it means it's a null character in UTF. all right. So in Java, you write this as a character backslash u 0000 UTF-16 2 byte, and it's all 0. But in C style character, we just escape this 0 with backslash, so that it becomes a null termination. all right. So because this function, again, get a string UTF-chars, gives us a raw pointer, we have to call the function that starts with release a string UTF-chars, and then JString and the characters here. So if it's a copy, when we do this, first of all, strings are immutable. So unlike arrays, that when we call the release array elements, there is no copying back to the original string, because strings are immutable. So it just, what happens is that JVM just deletes the copy that it creates, right? Because we don't need it anymore. So let's build this, and then let's copy and paste the dynamic library to our Java project in the JNI folder, and then let's go back to Java and run test 1. Okay, so is copy comes back basically true. So originally it's initialized to false, but when I call this get a string UTF-chars, is copy comes back true, which means JVM actually made a copy and gave me a raw pointer to that copy. And when we do this release, JVM deletes that copy. all right. And then as you can see, I'm able to get all the characters, all the string out of it. And the way this works is that this cout, when it gets a const char pointer, it's just like a loop. It goes into a while loop and increments the pointer until it gets to this null character, and then it knows that that's the end of the string. So we can actually manually write this. So instead of doing this, I can say while stchars, if I dereference this gives me the actual byte that represents the ASCII or UTF-8 encoding of the character. While this is not equal to the null, remember we have to escape this 0 symbol, I'm going to say std cout, basically dereference this character, and then I'm going to stchars just increment it, go to the next character. This is a pointer, I'm incrementing it, it knows that it has to go up by 1 byte, so it goes to the next character. And then the problem here is that I'm mutating this basically character, so then we have a problem in this release a string UTF-chars. But let's forget it for now. Maybe I can make a copy of it. So const char pointer stchars copy is stchars, and let's mutate this stchars copy. all right. So I'm just creating a while loop. Let's compile. It builds fine. Let's copy and paste the dynamic library, and then go back to Java. Let's see if our while loop is working fine. Yeah, so the while loop works fine. And again, behind the scenes, when we pass a CS style string, which is the pointer to the first character of the character array, to a cout using this insertion operator, it just does this kind of loop and goes until it dereferences the pointer and goes until it gets to the null termination, null character, basically null termination or null character. Now if we use the C++ string, then these things, this kind of looking for the null character already is handled by the internally handled by the C++ string, so we don't need to deal with it. But the problem is that JNI gives us C style pointers, right? Const char pointer or const jchar pointer, and then now working or dealing with the strings becomes a little bit more complicated, because it's a C style string, not C++ style string. I wish that they had actually updated this JNI interface for a string so that it can directly give us a C++ style string, but they haven't done it, and I guess they're not going to do it. But yeah, you can write a very small function yourself so that it just gives you a std string. All right. So again, in general, the way we deal with these characters is that we create a while loop or a for loop or whatever, and we loop increment the pointer until we get to the null character, which means now the string is terminated. Okay, and this works if we are dealing with character array, which means byte one byte at a time. Now the problem is that when we work with this critical, it gives us a const jchar pointer, and jchar is 2 bytes, not 1 byte. So basically then we have a problem because we cannot just directly convert it to a const char pointer. So let's go and try to run test2. In test2 we are going to use the get string critical. So let's copy and paste this code to the second function. So we still have this, let's also bring this jboolean. All right, we still have this jboolean, and now we are calling get a string critical, and this is supposed to give us a direct pointer to the string on the Java heap. So JVM is not going to make a copy, so we can just directly test it. So I'm going to comment this part out, and when we use get a string critical, eventually we have to call release a string critical, and we pass in a J string and then const jchar. Okay, so now this is jchar pointer, stchars. All right, so get a string critical returns a const jchar pointer, and the reason it's const because strings are supposed to be basically immutable, so they're constant. So let's copy and paste the dynamic library back. So I'm just printing out the is copy flag. So if I run test2, this hopefully gives me true, false, which means now in this case JVM is not creating a copy of the original string. Instead, it's giving me a direct pointer to the string on the Java heap, right? And this is good because if I'm dealing with lots of strings, I don't want JVM to just copy and copy and copy. That doesn't make much sense. All right, but then here's the problem. Unlike the first one that gives me a direct const char pointer and I just can push it to the stdc out, if I push this const jchar pointer, it's not going to print the entire string for me, and we can just directly test this. So I'm just pushing the stchars, which is a const jchar pointer, and let's see what happens. Let's go back to Java. Let's see what we get. So we get this hex number, and that's just, first of all, because stchars is basically a pointer, and pointer is just 4 bytes. So I'm going to see if I can cast it to a basically const char pointer, and then see what happens. All right, actually okay, no, instead of doing that, I'm going to just dereference this pointer and see what's the actual value of the memory address that this pointer is pointing to. So let's look at the dereference value, and let's copy and paste, and let's run the Java. So it points this weird number 72. So the memory address that this jchar pointer is pointing to has a value of 72. So what is this 72? So in order to understand this, we have to understand that jchar maps to an unsigned short, so which is an integer. So this 72 is is the value of the 2 bytes, the integer value of the 2 bytes, or the unsigned integer value of the 2 bytes that this stchars, this pointer, is pointing to. So what I need to do here is let's see what's the hex value. So if I push std hex and so that we see the hex representation of these 2 bytes. Let's see, let's build this again. Let's see what's the value of this, what's the hex representation of these 2 bytes which are residing in the Java heap, and it's 48. So right now what we're getting here is the hex value of 48, and that's basically 1 byte. Obviously the second byte is 0, right? So we are getting this. So what is this hex, 48 hex? So if you go to Google and browse for capital H character representation UTF-16, you see that the UTF-16 representation of the capital H is 48 hex, right? What this means is that what we are actually getting here, so the pointer is pointing to 2 bytes, and the hex representation of those 2 bytes is 48, which is correct, which means it's pointing to the H character, capital H character. It's pointing to the first character of this string, which is a character array. The problem is that in Java each character is 2 bytes. In C style string each character is 1 byte, UTF-8 or ASCII, right? So how do we loop? So again, because now this is not a const char pointer, unlike this case that I could just pass this const char pointer to the std_cout and it could basically understand how to deal with the CSL string. I cannot do this, right? Because this std_char, this pointer, even if I dereference it, in C++, it's treated as a short, which is an integer number, right? It's not treated as a proper character. So now let's do this. Let's say that instead of now we know that the first byte or the first 2 bytes are the encoding, UTF-16 encoding of the capital H, which is the first character. So what happens if I convert this jchar pointer to a const char pointer? What happens? So do I expect to see the entire string being printed? And the answer is going to be no. We will probably only see the first string, the first character of this string, and I'll explain to you why. So let's try to see what happens if we manually typecast this pointer to a const char pointer, so that we're telling C++ compiler, hey, treat this pointer as a character pointer. Let's see what happens. Alright, now it's printing the first character, which is H. So why is it that it's not able to print the entire string or the entire character array? That's again because how the how the C style string works in C++. So this cout function, this insertion operator says that, okay, I'm giving you a const char pointer, and then cout says, okay, I start from the first byte and loop through until I get to a 0 byte, right? A byte that is 0 0, or 4 bits or 8 bits are 0. Basically, if you look at the std_chars, all right, if I dereference this and look at the hex representation, it's basically 0048, right? That's the capital H in UTF-16. All right. So what happens here is that this 48 is the first byte. So when I convert this cout starts looping through. It sees the first byte 48 and it treats it as a character. But then when it looks at the second byte, it's 0, and it assumes that it's a null termination. So it terminates, right? So basically what happens is that we only see the first character. That's just because the second byte here is 0, and all the C functions, C++ functions assume that it's a null termination. So it's not going to work. So what we can do is we can actually manually loop through. So what I'm going to do, let's create a copy of this original pointer, and then while I'm going to say I dereference it and then compare it with a null termination. Know that when I dereference it, I get the 2 byte hex, and 0 character, basically if you look at the termination character, it can be basically in hex it's 00, or in 2 bytes in 0000, and none of the characters, when I dereference them, they are the 2 bytes is not 0. So again, this and therefore I can safely loop through and compare with the null character until I get to the actual termination point of this jchar pointer array, right? The UTF-16 array. So, and then what I do, I dereference this const char pointer, right? So now each 2 bytes gets truncated to only 1 byte, which is correct because we are using English characters, and English characters are backward compatible with UTF-8 or ASCII. And then we push this out, and then we increment the original pointer, which is 2 byte, not 1 byte, right? So this cout, when we convert the original stchar to const char pointer and pass it to cout, now cout increments by 1 byte because it treats this stchars as a const char pointer, which is 1 byte. And we know that if it starts with the 48, the second byte is 0, and it assumes a null termination, so it only sees 1 character. But here we are incrementing the jchar pointer, which is 2 bytes. And then each time we convert it to a 1 byte pointer and then do a cout. So this should work. This should be able to print all the characters. So let's build this. So we have a, so this should be a const jchar pointer. All right. So let's build this again. It builds fine. And then let's copy and paste the dynamic library. So this time, if I run the Java code, I hope to see all the characters being printed. Yes, now we're getting all the characters printed as we expect. And then the downside here is that we have to manually loop through the array and then do a UTF-16 to ASCII or UTF-8 conversion by just converting the jchar pointer, which is 2 bytes, to a const char pointer, which is 1 byte. And again, we need to dereference the memory value and then compare it with a null termination character, which is a C style, basically a way of dealing with characters. When we use this get a string UTF-chars, basically behind the scenes in the JNI, it automatically does this for us. It goes through this loop, converts all the jchar pointers, which are UTF-16 2 bytes, to 1 byte, and creates an array that now each byte represents the UTF-8 encoding of those 2 bytes, and then it gives us a const char pointer. So this is more convenient, but we already know that this get a string UTF-chars actually creates a copy, which is not something that we want if we are dealing with a lots of strings and sending them to C++. All right. So I hope you enjoyed this lecture and you now fully understand how the strings works, what is the UTF-16, what is UTF-8, and how we deal with them when we go from Java to C++. So please stay tuned, and I'll see you in the next one.